Hello everyone again. Today I have another Toyota Corolla Verso with 2.2 a common rail diesel engine. So the engine code is 2AD-FTV. So engine capacity is 2231 cc. So the car has manifold absolute pressure or barometric pressure circuit low input. So this is the fault code that is stored in the memory, and still the ignition is on and engine is off. So with the ignition on, engine off, we are going to go for the live data and see the live data of the score. That let's let me bring this and to, no, here is all right. So okay, so I have brought this topics to the top of the list, which is coolant temperature, manifold absolute pressure right now, which is 11.6 psi, and engine speed is 0, vehicle speed is 0, intake air temperature is 75.2 Fahrenheit, but I'm not sure that how many degrees of Celsius this is going to be. So mass airflow rate in gram per second is 0.45, and atmosphere pressure or atmospheric pressure is 14.5. so you take this in a note, and then I'm going to start the engine. So I have started the engine, and as you can see, why not focusing? Okay, as you can see, manifold absolute pressure drops to 8.99 psi. So the engine speed is 805 revolution per second per minute. Vehicle speed is 0, intake air is 57.2 Fahrenheit. The intake air temperature is 57.2 Fahrenheit. Mass airflow rate is 6.92 gram per second. So atmospheric pressure is the same. So at engine idling, the manifold absolute pressure drops to its 9.14. So the coolant temperature is 179, which is going to be, I'm not sure this is going to be, let me work out that's how much it's going to be. So 186.8, that's going to be approximately 85 or 86 degrees of Celsius. Now I'm going to rev the engine, and you see if there is any change in manifold absolute pressure. So the engine rev counter or the engine rev suddenly went to a maximum. I didn't press the accelerator pedal to that position to go the engine rev up to a maximum, so I slightly moderate the press the accelerator pedal, and the engine rev has gone up to the maximum. So it's very dangerous. Either there could be a injector leaking. So and also, as you can see, the injection feedback value of injector 3, that's very bad. So now I'm going to disconnect this injector and see if there is any change in the value. So injector 4 also bad, because the adding value is 5, adding feedback value is 5, which is no good, and the injection feedback value of injector 3 is -5, which is no good. So I have disabled injector number 3, and as you now you can see the injection feedback value has gone from -5 to +5, and also the injection feedback value of injector number 4 is now -0.5. so there is definitely issue with the injector as well. So first I'm going to investigate the manifold absolute pressure problem, or the P0107, I think, this code, and then after that we are going to investigate the fuel injector problem as well. So now I have brought the number 3 injector back to life from disability to life, and as you now can see, the injection feed back value is -5. It means that that injector could be severely leak, and the other one, injection feedback value of injector number 4 is +5, which is also no good. As you can see, the manifold absolute pressure changes, but it can't reach to 1 bar. It's below 1 bar. It's I cannot bravely press the accelerator pedal because it's the injection system is that much bad. I fear, or I'm worried that they not to damage the engine any further. So okay, we have the DTC P0107 explained in the manufacturer service manual for this vehicle. So P0107 manifold absolute pressure barometric pressure circuit low input. Low input means that the pressure value, or the manifold absolute pressure sensor senses low pressure, and that's the reason the output is low, or the sensing tube is blocked. This is another reason. The sensor itself is faulty. That is another reason. The air flow is restricted to the inlet manifold or to the intake valve through the inlet manifold. This is another reason that could be caused. Turbocharger defective is another reason. The charged air system flow could be blocked or clogged. That's another reason. Or the charged air or turbocharged air could be leaking somewhere. This is another reason. But here they say, let me read out that to you. The manifold absolute pressure sensor detects the intake manifold pressure by using the built-into sensor unit. The ECM determines the basic injection duration and injection advance timing based on the voltage output by the manifold absolute pressure sensor. The manifold absolute pressure sensor monitors the absolute pressure inside the intake manifold. Default is 0 mm of mercury, so that the ECM controls the air-fuel ratio at the proper level under any driving condition without influence of fluctuations in the atmospheric pressure due to the factors such as high altitude. And this is the small chart that they have given. As you can see, at 13.3 kilopascal, which is approximately 1.9 psi, the voltage would be 1 volt. The manifold absolute pressure sensor output voltage would be 1 volt. So as the manifold absolute pressure increases inside the inlet manifold, the voltage also increases. So at maximum, when the manifold absolute pressure reaches 253.3 kilopascal, which equals approximately 2.5 bars or 36 psi, the output signal voltage of the manifold absolute pressure sensor would be 4.5 volts. So the troubleshooting steps are here. So I have read out that to you. So there are any other. So we only got we don't have P0105 and P0108. We only have P0107, open or short in manifold absolute pressure sensor circuit for approximately 0.5 seconds or more. So one trip detection logic. So treble area, where is the problem could be located or could be laid. So open or short manifold absolute pressure sensor circuit, manifold absolute pressure sensor, turbocharger assembly, EGR valve assembly, ECM. So hint, when DTC P0105 and P0107 P0107 and or P0108 is set, check the intake manifold pressure by selecting powertrain, engine, and the EC. So that's their scanner, the Toyota factory scanner procedure. So where is that? Okay. So intake manifold pressure kilopascal approximately 0, then 250 or more, short in PIM circuit, open or short in VC circuit, open. So that's the connector code, that name, the pen code, connector pen code, VC, PM, or something like that, which is here. That's here. So manifold absolute pressure sensor, that's the pen, VC, PIM, and E2. So anyway, this is the procedure. Just let me explain to you. One second. So Toyota has given this reference. When DTC P0105 and P0107 and or P0108 is set, check the intake manifold pressure by selecting powertrain. That's their scanner procedure. Engine and ECT data list, PIM on the intelligent tester too. So the value they mention is that intake manifold pressure kilopascal approximately 0, then short in PIM, it means that the signal voltage of the signal wire of the inlet manifold absolute pressure. This is the signal wire, and they say the malfunction short in this wire. So if the inlet manifold absolute pressure reach 250 or more, 250 kilopascal or more, so the possibility is that open or short in VC circuit. VC circuit is the 5-volt reference wire. This one, this is the 5-volt reference wire. 5-volt reference voltage is supplied by the ECU to the manifold absolute pressure sensor. So open in PIM, which is the signal circuit or the signal wire. Open in E2. E2 means that it's the ground circuit of the sensor. So red is the signal wire, this one PIM. Yellow is the 5-volt reference supplied by the ECU to the manifold absolute pressure sensor. And E2 here, this is the connector pin number. So 1 is the ground with the brown color, and 2 is the signal output voltage from the sensor, and input voltage to the ECU, input signal voltage to the ECU, and pin 3 is connected with the yellow colored wire, and it's the 5-volt reference voltage supplied by the ECU to the sensor. So this is the manifold absolute pressure sensor. As you can see, it has 3 wires, brown. Let me, if I can show you the connector, the pin number as well here. Let me, if I can show you. So once again. I'm not sure if you can see. So this is one brown, one red is 2, and this one, as you can see, I'm not sure, I can see the yellow is pin number 3. So if I connected this to the sensor, the connector, so one is going to be the brown on the right hand side. If your face is toward the car and you are standing in front of the car, then number 1 is the brown one, and the middle one is number 2, which is colored red one, and the left this side is the pin number 3. So now I'm going to show you the function of this, as now you can see. So I'm going to prove the yellow one. So as you can see, 5 volt, this is the 5 volt reference voltage supplied by the ECU. And now I'm going to back prove the middle or red wire. So as you can see, it's 1 volt. So this is going to be the signal wire or the signal voltage you right now reading. And now I'm going to back prove the pin number 1. So I have back proved, and that's the, you just read 5 point something like millivolts. So this is going to be the ground wire of the sensor. But now I'm going to back prove the signal wire, the red wire. The red wire, I'm going to back prove this one. As you can see, you can see the reading is 1 volt. Now I'm going to disconnect the sensor connector from the sensor itself, and then you watch the. So as soon as I disconnected the connector from the sensor, the voltage has gone up to 4.9. So now, so whenever you have confronted this type of situation, because now let me if I can stable the camera somewhere, and then free my other hand as well. So now, to distinguish between the signal voltage while the sensor connector is disconnected, and distinguish between the reference voltage of the sensor. If you, for example, check that here, just 1 second. This is going to be the ground wire of the sensor, as you can see now, and the middle one, it's 4.9. Why it's not 5 volts? Because it's not 5 volt. The signal voltage goes through the resistor, and when you measure it here, that little bit drops in the voltage is, as you can see, it's 4.922. So that's the sensor supply voltage. The sensor supply voltage to the signal wire. And as you can see, the reference voltage, that's going to be 5.1. So it does not apply for all the cases, but in most cases, if the sensor has 2.5 volt, and the one, if you measure with the connector disconnected from the sensor, the level value 1 would be the supply voltage for the signal, which is here, the middle pin, 4.9, and this is exactly 5 volts. So that's going to be the 5 volt reference voltage, and the other is the signal voltage. If I connect the sensor and then take the value from the signal wire while the sensor is connected, and you can see, let me, it's not reading at all. It's not there. It's, the pen is not good. As you can see, while the sensor is connected and the voltmeter reads, one second. So the voltmeter reads 1 volt. So this is also a provement, that also proves that the sensor circuit integrity is good. There is no problem to the circuit side. Now I'm going to connect the hand operated pressure pump and apply some pressure to the manifold absolute pressure sensor, and watch changing in the signal. If that happens, then it means that the sensor is good. So we have problem at either restriction of the inlet manifold due to carbon deposit built in it, restriction in flow of the air, turbocharger defectness, or restriction in the air turbo air charge system. So now I'm going to apply some pressure to the inlet manifold pressure sensor, and while the pressure is applied, then we will take the manifold absolute pressure sensor signal value, or the signal wire output value. Okay, as you can see, the signal reading of the manifold absolute pressure sensor is 1 volt, and right now the ignition is on, engine is off, and pressure is 0. And this is the manifold absolute pressure sensing tube or connected to the inlet manifold down here. If you can see, just let me, if I'm able to connect it down here, just there, you know, the shining little knob can be seen. Just let me, if I, yeah, just connect it here. So as you can see, 1 volt, engine is off, ignition is on, pressure is 0. Now I'm going to apply some pressure, and let me bring this together. As you can see, able to see both. So if I bring this two together, okay, now I'm going to apply some pressure, and you watch. Look, as the pressure increases, it has gone to 5 psi, and the voltage has gone to 1.5 volt. So now I'm going to increase that pressure, 2 volt, and the pressure is, it's up now over a bar, just over a bar, and you reach 2.2 volts of the sensor output signal voltage. So when it's 30 psi, so the manifold absolute pressure signal voltage is 3.477. Now I'm going to show you that whether the same thing is read by the scanner as well, or the scanner may read something different. So now I have, so as you can see, the scanner reads 11.89 of inlet manifold pressure, and the inlet manifold, the manifold absolute pressure sensor output voltage is 1.138, and as you can see, no pressure applied yet. Now I'm going to add some pressure, to apply some pressure to the manifold absolute pressure sensor, and 1 second, because the timer is reached to the off point for the voltmeter. So I'm going to, yeah, this is I have applied 21 psi of pressure to the inlet manifold pressure sensor, and as you can see, the voltage of the inlet manifold pressure sensor, the output voltage or the signal voltage is 2.818. And watch here, manifold absolute pressure reaches 29 psi of manifold absolute pressure. It means that our electrical system or our electric circuit for this is okay. We have problem somewhere mechanically. Either could be the inlet manifold clogged, the charged air may be restricted, or the turbocharger unit could be defected as well. So as you can see, it's 28.86 psi with the sensor output voltage 2.8, and the it's like that the inside of the manifold pressure is 20 psi. So because the computer is calculating the value differently, we only applied 21 psi of pressure, but the computer is collecting that differently, because if you bring that to 0, we have brought the applied pressure back to 0, but computer still read 11.6 of psi pressure. So the computer is calculating the manifold absolute pressure differently. So it's a bit complicated, but later I will explain that to you as well. So now the voltage has dropped back to 1.05, and so now I'm going to dismantle or remove the inlet manifold, and I'm going to share that with you if that's clogged or there is air flow restriction, and then we will go ahead with that one as well. As you can see, I have started the engine is running. Now I'm going to connect scanner to the vehicle and see what is going on. So I have cleaned the inlet manifold. The EGR valve was already cleaned because a few days ago I cleaned the EGR valve as well and put the inlet manifold back, put everything back. And now I've started the engine and now I'm going to connect the scanner that I'm going to see that how things are going on. So I'm going to the live data page on the scanner. Live data page. The engine is running. Let me coolant temperature, engine speed, manifold absolute pressure. So unfortunately the manifold absolute pressure did not change. In spite of that, we clean the manifold, inlet manifold and the inlet manifold ports to the inlet valves, so but the manifold absolute pressure still reads low. Okay. As you saw, the manifold absolute pressure is 9.14 psi. Now I'm going to take the manifold absolute pressure sensor signal value. As you can see, we have same value. Either if we use the sensor ground or use the battery ground. So we have 0.8 volts at engine idling. Now I'm going to turn the engine off and ignition on, engine off, and take the value of the sensor signal wire. So now the ignition is on, engine is off, and the value of the manifold absolute pressure sensor signal wire 1 volt, 1.070 volts. So unfortunately the problem is going to be with the turbocharger unit. So I'm going to inform the customer that the problem is mechanical problem, it's not electrical problem.